So let's say you have a really cool flashlight shader that you figured out how to implement using vanilla shaders, and you want to turn this thing on and off. Well, this resource pack essentially makes it so you can toggle the shader on and off using just one command. There you go, just that command there just turned it off, and this command here just turned it on. That's really all it takes, very simple. And today we are going to go over, this is essentially the second version of this shader selector pack, but this is kind of the final and ultimate best version for flexibility, multiplayer compatibility, and all of the above. This is just overall the best. So we're going to go over how to implement and use this shader pack, as well as all the nuances behind it. So as I said before, it really is just one command. And what command is that? It is actually just a particle command. So this is a variation of the shader pack that I did before, but this one has a lot of code used from Der Disco Hund, which I will link his original GitHub in the description. But I essentially took it, applied my kind of generalized version to it so that it looks a lot cleaner in terms of implementation and trying to add things on. It's a little bit more user friendly in the naming conventions. So I'm going to go through it and show you how it works. So in the description, there will be a GitHub link, and in the GitHub link, it will link you to releases, and the latest release will have a zip for the flashlight example, resource pack, and data pack. The data pack is just some logic behind it, and the resource pack is everything you need. So let's take a look at the resource pack and see exactly what it's doing. So all we have is just shaders and a couple textures that will be useful later. So the shaders essentially go to the particles. They go to every particle in your world. And what they do, this is from Der Disco Hund. I did not write any of this code myself, but this is from him. So essentially what it does is it looks for particles that have a red color of 255, okay, and a green color of 253 or 252. So if you have that two color combination, which will almost never happen naturally unless you have some kind of specific command doing it, then if you have that two color combination, then that color is considered a marker or something that the system will analyze. And what it does is it moves it to position 0, 1. So the bottom left-hand corner of your screen down there. Okay, so it moves it down there to be used later and evaluated by the shader system. So then let's pull out of core and let's take a look at post. So in transparency, you have a color and a color swap. These are just buffers that will actually hold the colors for the different channels and various things that you will save for later. So this is how you toggle and not just tell it to turn on in that sense. So this actually lets you kind of change states, toggle, turn on, off, change values. So the way that happens is you copy the previous buffer's value onto the copy of the buffer. So you copy the buffer onto another copy of it, and then you process that the current frame's color system, and the copy is the input, so we can look at the input and compare it and then put it on the output. And then you use this special shader, which will remove any colors in the bottom left corner of your screen that were done from that shifting. And then finally a transparency pass, which is just something vanilla, something happens normal. Then after the transparency pass, this is when we apply our shader, which is what you really have to care about in terms of how to use this. And in this case, I also passed flashlight sampler, which references a texture called flashlight in the effects folder. So that's how you do overlays. You basically put a texture in the effect folder, and this name will be the name of the texture that you can reference like this to use as an overlay. Okay, so then let's go and look at these programs. So I'm just going to basically jump through these other ones that you don't have to worry about. I'll just go through them very quickly. So the way find color works, this is how it figures out which color you're using for which channel. Essentially, it is going through that buffer, which is has 3 rows. And if you are on row 0, it actually adds a time variable that it keeps track of, which this is useful for if you have kind of like you want a timer and you want something to have like an animation. And I left it in here. It was useful for his use case, not really useful for stuff that I work on, but it can be useful for you in the future. So you can use this time variable if you need to. But we're really focusing on row 1 and row 2. So row 1 is if the color matches 253 for green, and this 254 for red. It's not 255. I said 255 earlier. It's 254. And then the row 2 is if it's 254 for red and 252 for green. So these are your two different channels. And the output location is to row 1 and row 2. Okay, so if they match, then it's going to set the color. If they don't match, then it will just set the color to whatever the last value was, which is why you need that duplicate buffer, essentially. Okay, and then remove, we're not going to look at, but it basically removes those textures of the shifted things. Now, this is the part that you need to care about. This is the shader folder. So the core is not going to have this flashlight pass. It's not going to have some of these uniforms, but you can add them if you need to. So essentially, it'll run a vertex and a fragment shader on the screen at the very end. And this is where you can apply your special effects. So here, essentially, there is a lot of code to look at, but you just need to focus on the fact, and I will go over what the core, let me open up what the core one looks like because it's a lot cleaner. The dev, it is a lot less to look at. So we're going to open that one just as a comparison. So this is really essentially what is happening. So we have channel 1 where we fetch the texel. We do a texel fetch, which grabs the pixel that is at position 0, 1 in the buffer for your control buffer. So your control buffer is the control sampler here that you passed, and it has 3 rows. So you fetch whatever color is at that location, and then you use a switch statement on whatever the blue channel is. So channel 1, we will pick to do stuff depending on what its blue color is. So if the blue is a value of 1 out of 255, then in the dev version, it just shades the screen. Then for channel 2, you do the same thing, but to the green channel, which is channel 2. And likewise, if you wanted to, you could have more channels just by basically parallelizing this. I will leave that up to you to figure out how to add more channels. 2 was enough for me, but you basically would just copy this, make another, and you would have to go to all the other locations where it says row 1, row 2, row 1, and row 2, and you'd have to add a row 3 option. Then also there's this overlay, which is if you want to use overlays, it will mix the overlay variable, which is you can think of as like a pixel, and it'll mix that with the screen. So this is if you actually use overlays. So in this example over here, we actually use overlays. So basically what I did for the use case is if the color blue is 1, then apply the flashlight shader, which basically figures out how far away the pixel is that you are looking at or coloring in this pass, and it applies some brightness to it depending on the depth and distance from the center of your screen. Then channel number 2 is the overlay. So this is the control of the battery in the top left. And let me show you actually what that looks like. So when I have the flashlight on, it kind of deteriorates until I run out of flashlight and it turns off. So you can just run /function ss refresh, just so I have all my battery left, and I can right click, you see it turns on, the battery in the top left counts down to 0, and then when it's 0, it takes it off. Okay, so essentially the way that works is it sets a value for the battery value based on the blue value. I really could have made this less code if I just said battery equals blue channel, but I wanted to be more explicit in this case statement structure so you can understand that. So if the blue channel is 1, then battery is 1. If blue channel is 2, battery is 2. If blue channel is 3, battery is 3. If blue channel is 4, battery is 4. Okay, so then the overlay basically shows you a window of this texture based on the height of the battery, based on the battery value. So if I go back, and then I go to Minecraft textures effect, you can see that this, and this is Fire Alpaca. This has every single option. And they're all the equal size, but it picks a different Y value to use or a different height to use depending on the value of your battery. Okay. So that's pretty much it. That's how you use it. You make it, put a new case statement with whatever, or modify previous case statements with whatever logic you want to apply to your colors in your shaders. You can also pass the control sampler to a different shader if you want better organization, if you don't want to do it all in one shader file. You want some organization going on so it doesn't get as messy. You could just do another pass. So the way that I would do that is I would essentially go into shader post transparency, and I would go here where it says toggle shader. I would just add another one. Make sure that you, instead of passing from swap to final, you do swap to, well, you can do swap to final, and then in your own other shader, it would go final to swap, and then you would need another blit that goes swap to final or to go from swap to main. But in the end, you have to output at main, and main needs to be outputted at the very end. Otherwise, the depth sampler will not work, and some things get buggy. So just make sure you're passing to some intermediate variable. In this case, I passed to the final, and then I copied to main. You can pass to something else, and then pass that something else to something else. You can't make the input the same as the output, otherwise it breaks. All these kind of things. I have a lot of videos with tutorials on how to use shaders if you're interested in getting into them. If you're not as experienced, I have some stuff where I go in depth on how the flashlight shader works and other shader stuff works. Okay, so that's pretty much it. If you guys have any questions, let me know. I'll be sure to answer them as soon as possible. The GitHub is linked in the description, and have fun using this. I mean, it's a very powerful tool. One caveat, though, is you have to have your graphics on Fabulous. Otherwise, the transparency shader doesn't even run. So there is that disadvantage. You have to tell your users turn on Fabulous. But other than that, everything works perfectly. It's multiplayer friendly. Why is it multiplayer friendly? Because I can play this particle over here while it's anywhere in my rendered chunks. This is some stuff I did not discuss. As long as it is in my rendered chunks, it will affect the shader. You saw it affect there. The other reason why it's multiplayer friendly is because with particles, you can specify certain players. So I can do force at S, and then it will only display this particle for me and not other people. So that is why it's multiplayer friendly. Another thing that is interesting to note is if you try and toggle both channels at the same time, well, you have to play two particles, and since you play two particles, they overlay each other and they just don't work, which is why in my implementation inside the data pack, which I will just go over briefly here, we go into here, data packs here. My implementation in the data pack is a ticking. So every tick, if you don't have the flashlight on, it tells the shader do not have the flashlight on, just to ensure that it has it. You could add some kind of artificial delay, but it's hard to know the timing on that. So I just spam it, and it's a particle. It's a single particle. It's not that inefficient. Anyways, that was it, guys. Pretty great system. Only caveats, you got to play particles on repeat at different times, but other than that, it works perfectly multiplayer, and I'm really happy with this. I don't think that there's any changes I would make or improvements unless they add a /shader command. So other than that, guys, I will see you next time. Peace.